I'm going to try this a little different for this lesson. The last lesson I did covered section 6.1, and that was, I wanted you to get a head start if possible. I am going to try to do a blend of 6.1 and 6.2 today, which is what I'm hoping to do in class coming up for our in-class lesson. But there are certain details that I'm going to cover that you may need to look at in 6.1 that I'm not covering here. So I want to first do an overview. Well, let me also warn you, 6.1, there's a formula at the very end about sample size, and that's a very important formula that'll definitely be on the test. Make sure you don't skip over that. I don't know, if I'll get to that in this, but I did cover it at the end of 6.1. So what is 6.1 and 6.2 about? They're basically about predicting the mean, this population mean. The population mean, which you should know the symbol is mu for the population mean, and it's when you have a sample using a sample. So let's just take a little bit of review again. You need to know all these symbols. We reviewed them in class this past week when we did section 5.4. If you were there, we did them in chapter 1 and chapter 2. So I'm going to use your survey question again as a example. Some students who did that project, you had Stark State students as their population. So if that was the case, that would be all Stark State students or whatever your population is. But you only sampled 50. Your N, your sample size is 50. So of course, this big square is the population. It'd be all the people or items that you're talking about. And this little thing is the sample. Now, when maybe you ask the question, how many Facebook friends do you have? We do not know the population mean. We want to predict that though. How would we predict that? We would use the sample mean to predict that. And that's actually called the point estimate. And this is review. The point estimate for a population mean, and I'm going to abbreviate here just because I don't have space, equals the sample mean. You need to know that. So if I find my, this is X bar. Whoops. Let me just see if I can erase that and make it a little prettier. Maybe make my circle a little bigger. X bar is my sample mean. Let's see. Sample mean. Okay, and so I would use X bar to predict my population mean. But most likely, when you take a sample size 50 out of a big population like the Stark State students, all the Stark State students, that sample mean's not going to exactly predict it. So what are we going to do? We are going to stretch that out to an interval. So let me draw a picture because a picture is really helpful. I got a number line. And let's say my sample mean is some number on my number line. Okay, that's our point. You see, it's a point. That's 1 point. It's a point estimate for my population mean. It's my guess for the population mean as one single point. But we know that probably isn't right on the head. So we are going to stretch our estimate out to be an interval between one and another. And the length, the distance on either side from the point to the outside is going to be E, which is the margin of error. So E is the margin of error. So we're going to have a formula, or we already have a formula in one case for the margin of error. We're going to have two different formulas, and what it's going to depend on is if you know. Now let's talk about standard deviation. Remember the symbol for population standard deviation is sigma. Sometimes we will know what sigma is. That's for things like heights of women in the United States. That has been well studied. So we know it's usually a bell curve, and we know usually enough information where we know the population standard deviation. But there's other things like your survey question. You probably don't know the population standard deviation. For instance, if I asked all Stark State students how many Facebook friends you have, if I asked 50 Stark State students, I'm not going to know much about my whole population for that. That has not been well studied, probably. So then but I can't always calculate my, I'm getting really messy here, my sample standard deviation. So remember, this is standard deviation. So if I know my population standard deviation, like for all people or all items that you're studying, then you're going to do it one way. If I don't, I'm going to do it another way, and I'm going to use my sample standard deviation, which is S. S is the sample standard, I'm going to abbreviate here, deviation. I'm going to use that, and I'm going to use a whole different, the procedure is going to be the same for both, but you're going to use a slightly different formula, you're going to use a different table. In fact, let's talk about that. I'm going to go and show you part of my PowerPoint. Whoops, wrong thing. Where's my PowerPoint? There it is. And let me X out of where I'm at. When we know the population standard deviation, when we know what sigma is, then we can use our standard normal curve. We can use our table that we've been working with for the last 2 weeks. But when we don't know it, we're going to use what we call a t-distribution. So a t-distribution looks like this. And let me see what this says on this slide. Okay, I'm going to go to the next slide. There's lots of details in my PowerPoint that are not on this video lesson. So the t-distribution is actually a series of different curves that look very similar to the bell curve, but their tails are wider. And we have a term called the degrees of freedom. This is the main thing you need to know that's kind of new, and then how to do this table. The t-distribution has something called the degrees of freedom, and it's simply, here's the formula, degrees of freedom equals n minus 1, and n is always your sample size. So I could try to explain this, but it's just going to take a lot of time. Just write this down and just take my word for it. And then I'm going to show you how to use the table. We need to, so this is outdated. Your table is in your packet if you were in class to grab a packet, or it's in the materials under chapter 6, materials. And this is outdated. So we are going to use the table, define what we call the critical values, which is a T with a little C down below. T because we're using a t-distribution. For a 95% confidence, I need to correct this, confidence level, confidence level when the sample size is 15. So let's write down what we know. We know that C is 0.95, and we know that the sample size is 15, and then the degrees of freedom would be 15 minus 1, which is 14. Then we're going to find our table, which is, so you need to pull out your table or pull it up, and you're going to find your confidence level here at the top. And the one tail and two tails is for something we're going to do in chapter 7. So confidence level at the top, and then your degrees of freedom here. And so what we call the critical value is 2.145. Because it's T sub C because we're working with the t-distribution. So that's how you use the table, and that's just a little piece of what we're going to be doing. I do want to make an important point about the table. If your degrees of freedom, if the degrees of freedom you need is not on the table, then use the closest degrees of freedom that is less than the value you need. So, for example, if your degrees of freedom is 55, 55 is not on the chart. Let me show you. Let's keep using C equals 0.95. So this is the table right here, what it looks like. I'm actually going to pull, there we go. So I'm going to use I'm going to look at the 0.95 column, but if I look down my left, the degrees of freedom, there's 50 and there's 60, but no 55. So it says to use the one closest but less than. So I'm going to use the 50, and then I think it's 2.009. So I'm scrolling up from there to see if I'm doing a 0.95 confidence level. My T sub C would be that. And by the way, there's 3 pictures. If you look at the right-hand side here, there's 3 pictures. We're looking at the top one. That's what we're working with. We're kind of trying to predict that our sample mean is in that interval. So that's kind of related to what we're doing. So I've just kind of introduced the basics for this section. The very next thing I'm going to do on the next PowerPoint is probably the most important thing to have in your notes. When you're trying to find confidence interval, I have listed the steps for doing it. If you know what I'm talking about on each step, and you can just follow those, you should be able to do the test or the quiz that I'm going to give you, or your project that you're going to be doing.